Are you able to see my screen, sir?
Yeah.
So our first session here is Dr. Vijaypal Singh Rathod. Dr. Vijaypal Singh Rathod has received his MTech in Information Security under the Department of CSE from Maulana Azad National Institute of Technology, Bhopal. He has completed his PhD in Design for Trust Technique for Trustworthy System Design under Department of Information Technology from ABB, Indian Institute of Information Technology Management, Gwalior, India, in 2014 and 2020 respectively. He is currently working as assistant professor in Department of Computer Science and Engineering at PDPM, Indian Institute of Information Technology Design and Manufacturing, Jabalpur. He has published over 10 research articles in international journals, conferences of reputed conference of reputed, including IEEE transactions. His research interests include hardware security, applying machine learning and IoT for different applications, hardware accelerators, cloud computing, and cloud computing. He is also member of IEEE since 2017. Welcome, sir. Our next session chair is Dr. Rajesh Kumar. Dr. Rajesh Kumar is a tenure track assistant professor at Hofstra University, Long Island. He was a visitor at the Department of Computer Science of Haverford College during 2019 to 21. He earned his PhD in computer science from Syracuse University. He has obtained his master's degree in computer application and applied mathematics from Jawaharlal Nehru University, New Delhi, and Louisiana Tech University, respectively. He has more than 7 years of research, 3 years of teaching, and 4 years of industrial experience as a software development engineer and an executive officer. His research focus are on enhancing the power of ever-evolving smart devices, wearables, and machine intelligence to solve security, privacy, and healthcare problems. Thank you, sir. Thank you for joining this session. May I request all the session chairs and participants to turn on their video. In this session, we have 5 papers to be presented. May I request all the session chairs to lead the session.
So who is going to start? Dr. Rathod, would you like to start?
Thank you very much, sir. Sir, very good morning, sir.
Okay.
Very good.
Yeah, so
can we start, sir?
Sir, let me introduce about you. Just a minute. So our next session chair joined immediately right now is Dr. Raghav Prasad. So let me introduce Raghav Prasad, sir. So Dr. Raghav Prasad, sir, is currently assistant professor at Department of Mathematics, Indira Gandhi National Tribal University, and he did his PhD from National Institute of Technology, Silchar, Assam, in August 2015, and MSc from Government Model Science College, Jabalpur. His area of research interest related to computational intelligence, including algorithm design, real-world applications, etc. He has about 35 reputed national and international publications and attended about 42 organized around 10 workshop seminars, etc. Also, he has completed 1 UGC project and have 1 ongoing project sanctioned by DSP SERB New Delhi. Welcome, sir.
Thank you. Thank you. So very good morning to all, and good morning to all participants. So I am requested to our colleagues, Rajesh Kumar sir, can we allow to from 176 paper, sir, ID?
Yeah, sure.
Yeah. So there are 5 paper in our this technical session. So the first paper is 176 paper ID, and the author is Milan Bins, Matthew, etc. And the title of the paper is Banana Depends Identification and Classification Using Hybrid Model with RESNET 50 VGG 16 and Machine Learning Technique. So I Request to author, please present your papers, please. Paper ID 176 available?
Yeah, I
Yes,
think
yes.
Milan is trying
he
to
is
share.
there now, so he can share their screen and then start.
Okay, okay, sir.
So Milan, you have about 9 minutes, and then we'll have about 1 to 2 minutes of question and answer. Okay. So try to finish it by 11, 14, 15.
Sorry to interrupt, but all the presenters are requested to wait till last. They are not left meeting before all the meetings are over.
Arre.
क्वेश्चन आंसर सेशन के लिए बोल दो, मैं कर रहा हूँ। तो क्वेश्चन आंसर सेशन ईमेल करने में ही हो जा रहा है यार। Saturation and heart rate readings when we are using pulse oximeter. When we are using pulse oximeter, the real time device. Sir, am I audible, sir? Yes, please. Sir, as I understand, I mean during our interview here, we had studied that the.
So Milan says he will rejoin in a minute. Something.
Okay, sir.
So
Yeah.
I think those who are ready, they can start.
We can start now. Yes, sir.
Yes.
Yes.
Otherwise, we will get late, sir.
Hmm.
We have to finish, I think.
So
So,
paper 209, which is by Ayush Misra. You can go ahead.
Yes, sir.
The title is Food Recipe and Nutritional Information Generator.
Is my screen visible?
Yeah,
yes.
Yes. And so 11:16 should be your timeline to finish.
Yes, sir. Good morning, respected session chairs and everyone. Today I'm going to present our paper titled Food Recipe and Nutrition Information Generator. Myself, Ayush Mishra. I'm a fourth year student from MNNIT Allahabad. My other team members are Ayush Gupta, Arvind Sahu, and Amit Kumar. We have done this work under the guidance of Dr. Pragya Dwivedi, MNNIT Allahabad. As we all know, food is very essential for human life and fundamental to the human experience. Having a healthy diet is important for an individual. However, an increase in the production of processed foods and growing urbanization have led to a change in lifestyle and dietary patterns. Individuals are now taking more processed food. As food enthusiasts ourselves, we wanted to build a solution for all other fellow foodies using computer vision to give them a holistic information about their food based on factors like ingredients, calorie intake, etc. One of the most fascinating applications of computer vision is in food related tasks, such as detecting food contamination, estimating freshness, food recognition, etc. Food classification is a challenging task since a single food product can contain different ingredients. Sometimes similar kind of food products have different ingredients. For the food classification task, previous works were mostly concentrated on basic machine learning algorithms like random forest and SVM. He and others use ingredient-based food recognition method. Boussard and others use random forest and SVM to classify the food pictures into different food classes. More recently, deep learning is being used for food recognition tasks. Like Liu and others achieved impressive state-of-the-art food detection results using deep CNNs. Currently, calorie tracking is mostly carried out manually or using various applications. However, these require a lot of user interventions. Previously, Liang and Li used faster RCNN and graph cut algorithm to calculate the food volume and hence its calories. Their experimental results showed that their estimation method was quite effective. More recently, Liang and others proposed a method where they tried to get the volume of the food by using 3D reconstruction methods using depth cameras. Subsequently, they calculated the weight and hence the calorie of the food item present in the picture. Now coming to the problem description, we know India is a storehouse of plethora of cuisines. It is all the more important for us to have appropriate knowledge of our dish, since the method of cooking and ingredients in a recipe varies from place to place. We very often encounter new kinds of dishes and we want to know what is the name of that food, what all ingredient it contains, its calorific values. People are now becoming much more health conscious. Everybody wants to keep themselves healthy. As a result, we have tried to build an application that returns the most related recipe to the user along with its calorific value when given an Indian food image as an input. The recipe includes information such as ingredients, corresponding instructions for how to make it, cuisine type, etc. to help guide the users. Now coming to methodology, we have divided our application into two phases. In the first phase, we have did the food recognition part. Once the food has been recognized, in the second part, we have used MIsp CNN to calculate the food area and hence its calorific value. For this work, we have used our custom Indian food image dataset, which we have collected from various sources using Selenium and Beautiful Soup. On the dataset, we have applied various data augmentation techniques such as cropping, zooming, flipping to increase the variety of image samples so that we can prevent overfitting. Also, we have annotated a subset of the dataset for calorie estimation task. Now coming to food image identification, we tried on different models to check their accuracy. We first started with a baseline model consisting of 4 convolutional and 2 fully connected layers. We then used transfer learning models which are pre-trained on the ImageNet dataset. The transfer learning models which we have tried are ResNet 50, ResNet 101, Inception V3, and DenseNet 121. Basically, these transfer learning models which are pre-trained solve the problems of vanishing gradients and slow learning in deeper networks. Food calorie estimation. So we have used MIsp CNN to calculate the food calorie based on the food area. So MIsp CNN is a state-of-the-art image segmentation method developed by Kai-Ming He. This method takes an image as an input and gives mask of the identified items and bounding boxes. So for food calorie estimation part, we needed the real size of real area of the food items, which is not always possible through a camera. So what we have done is we have used MIsp CNN to calculate the mask area of the food image and mask area of the plate. Once we have both those areas and we know the dimensions of the plate, we have used the below mentioned formula to calculate the food area. Once we have got the food area, we have used our pre-collected data on calorie per area to get the calorie present in the food item in the image. Here is a small demo video of our application. Here we can choose an image. In this example, I am choosing image of a roti kept in a plate. And once we click the get the recipe button, we get the information about that particular food item. In another example, I've chosen khichdi as an image, and once I click the get the recipe button, I get the related info about that food item. Now we tested different model architectures for food recognition tasks. For our case, the best performing model was pre-trained ResNet with some unfrozen layer. We also tried various tuning approaches such as unfreezing the top layers of pre-trained models, data augmentation, dropout layers, we tweak learning rates, and different hyperparameters. From our work, we can conclude that mask RCNN can be used for food calorie estimation. One limitation or application is that it predicts calorific value based on the area of the food item. And since our model has been, mask RCNN model has been trained on top view image of the food items, hence if a user uploads an image that is not top view, our application can give wrong predicted calorific value. Hence the image which the user upload always has to be the top view. In this paper, we have shown the methods which we have used to develop our food recipe and nutrition information generator. Our platform could help people attain a more sophisticated understanding of their diet and enable them to express themselves through new recipes and cooking techniques. In future, we intend to develop methods to estimate the food volume so that we can make calorie estimation with much better accuracy. Also, we can use ingredients to predict the amount of various nutritional labels such as fats, proteins, and carbohydrates, etc. Thank you for having me here to present our paper.
Okay, so Ayush, you have just identifying the nutrition present in the food, whatever food you are taking. है ना? So just I want to ask you, how are you going to verify or validating your approach that whatever nutrition you have found in a particular image of the food that are correct or not?
No, sir. Actually, we have not done this part of calculating the amount of various nutritional label as such. We have included this in the future work. Currently, our model, let me show this again. Currently, our model can give the recipe name, ingredients, preparation time, course, calories, and instructions to prepare.
So that the parameter that you have fetched, so how are you going to validate these parameters are correct or not? The question is that.
I mean, for the calorie part.
Yeah. So how you can ensure that the fetched parameter are correct or not, or how much it is correct?
So actually, what we have done is we have taken a food item of known calories, and then we have tried our application to predict those values. And we found that our application can predict those calories with decent accuracy.
No. How much accuracy that you have not shown in the presentation?
Sir, actually, it is there in the research paper. There is a table of 10 food items. I'm not included here. Sorry, sir.
No, so how much you have achieved? You can tell
No,
the number.
No, I'm not calculated the accuracy. I've just shown what is the value of the calorie of the food item and what is the predicted value by our application. So, like in the case of a roti, the calorific value of this particular item was 69 calories. However, my application gave 79.2 calories.
Okay. So you have also considered mask RCNN, where
Yes,
you are
sir.
considering the object. So how many nutrients you have considered in that mask RCNN? So based on that, you have extracted that bounding box for that parameters.
Sir, currently our mass RCNN model can support 10 food items.
10.
Yes, sir.
No, I'm not talking about items. I'm talking about the objects that you are on nutrients that you are considering in that mask RCNN.
No, we don't have to consider the nutrients. So basically you annotate the data set on the basis of that annotated data set, the mask RCNN is trained to detect the food item.
No, actually mask RCNN, whenever we are going to detect something in the image, so image can be different, but whatever objects you are going to detect, that based on that object, it provide the bounding box.
Yes,
so
sir.
I'm talking about the number of objects or what type of object that you have considered.
No, I'm detecting the food items.
Okay.
Okay. Anyway, follow-up questions can be done later because in the interest of time, we should move forward with the next presentation. Thank you, Dr. Rathore, for the questions. I think those were valid questions.
Yes, sir.
question.
Sir,
Right.
actually, I have one question only.
Yeah.
Hello.
Yes, sir.
But actually, you are used some parameters, hyperparameters. Can
Yes, sir.
you tune the parameter? You are tune the parameter? Or
Yes,
direct?
sir. So I didn't get your voice. Yes, sir.
Whatever you use the hyperparameter, are you tuned or directly used?
So now we have tweaked those parameters. Like first we started with some particular value, then we changed them and observed our performance.
So you are tuned. Okay, thank you.
Thank you, sir.
Okay, sir, done for this.
Is Milan ready to go? Or should we just wait?
Yes,
Milan is here.
am I audible now, sir?
Yeah, you're audible. So please
Yes.
go ahead. And
Am I
you
audible
should,
now, sir? Oh, okay, sir. Yes, sir.
yeah, you should finish by 11:30 maximum.
Maximum, yes, sir. Yes.
Yeah.
Yes, sir. I'm sorry for, I apologize for the earlier inconvenience caused. So, first of all, I'd like to wish a very warm good morning to the session chairs, the organizing committee of MIsp 2022, and the National Institute of Technology, Raipur, my fellow authors, scholars, and researchers. So, my name is Milan Vince Matthew, and I am a student at Vellore Institute of Technology, Chennai. And our paper is titled Banana Ripeness Identification and Classification Using Hybrid Models with ResNet 50, VGG16, and Machine Learning Techniques. So, the background of our study was vegetables and fruits are like a part of the balanced diet and something that we consume every day on a daily basis. But the thing is, vegetables and fruits have a very short shelf life. So we chose the fruit of banana as it is widely consumed, around one of the most consumed fruits across the world. And countries like India are the biggest producer of the fruits. But every year, a major portion of the fruit is wasted due to the mismanagement of the product. Like an average banana has a shelf life of less than 5 or 7 days. So if it's not managed properly, once it's the value of a banana is associated with its ripeness. Even unripe bananas can be used for some form of cooking, but once it's overripe, it is more or less useless and is thrown out as waste. And recently, with the onset of the COVID-19 pandemic, uh, the e-commerce grocery centers such as Big Basket, GeoMart, they were primarily dealing with the customers, and we never used stores due to the restrictions and the lockdown. So at this particular moment, most of the fruits and vegetables were brought into the huge warehouses of these major companies and were sorted based on the fruitness, ripeness, and all that. So in that particular situation, the existing one of the common methods was to use manual people, like humans who actually work in sorting out this. But this is an exhausting and very tedious task, and is often not that much accurate, as humans suffer from decision fatigue and other physical restraints. So that's why we decided to implement a model that can classify bananas based on their ripeness. And this output of the model can be fed into segregators or other pick and place robots to partition the robots into the bananas into different categories and use them accordingly, so that minimum wastage of the fruit, and we can use it is very helpful for it gives a major contribution in preventing the in resolving the world hunger issue as well. So as part of this, we researched a lot of papers, and some of the most influential papers were one by Irsal Ahmed Sabila et al., who used machine learning techniques solely for this
I
purpose,
think,
and they
sorry to interrupt, Milan. I think they only answer
Slide.
first slide. So Milan had not shared whole screen, I think. So that's why we are unable to see. Am I right, sir?
Yes, yes, yes.
Yes.
Yeah, slides are not visible. Maybe make it in
Milan, just first
presentation mode.
unshare and share whole desktop. Then I think all the slides will be visible. Actually, in
okay,
full
so
screen mode. Yes.
yes, I 1 second, sorry. Is it visible now,
Yeah.
sir?
Yeah, it's better.
Yeah, this is okay.
Yes, sir. So I was talking about the problem statement and the background study so far from here. And moving on, this was the literature survey that I started talking right now. So the paper by the study by Savila et al., which used machine learning techniques solely for this classification purpose, was one of the primary reasons. No, was one of the first papers that we read and was influential in the study. So they try to determine the best method from KNN, SVM, and decision tree approaches to solve, and they were able to find the highest accuracy from the SVM method, and the reported accuracy was around 95%. But with further reading of the data set, we found that the data set was not very huge and showed signals of overfitting in their technique. And then the next study, which used a more modern approach, was by Kuriati Kipli et al., who where they used the Google Cloud platform. So in the Google platform Cloud platform, there is a specific application for analyzing pictures and especially based on color extraction features. So their study basically what they did was they uploaded pictures to this Google Cloud platform using an API, and based on the color RGB HSB values, they used a formula to categorize the bananas into ripe, unripe, overripe, or mid-ripe categories. So so our problem, we decided to take it up and solve this, and we didn't want to, like, though we in the paper suggests for banana ripeness, we did not want to specifically make this only for banana, since that would be a impractical approach for a real world industrial usage. So, and that was a common thing that we saw in many research papers where they have actually used research they've actually used some formulas and the area of brown area to the ratio of brown to yellow color in bananas as a factor to calculate ripeness. But the problem with such models is that they can be used only for bananas. Once we try to move to another fruit or vegetable for the same purpose, like if this problem is associated with everything, then the engineers must start from scratch again to start designing their models based on another factor. So we did not want to uh, go that way, and we wanted this model with modern techniques such as transfer learning to be applied to other fruits and other classification problems as well. So, and then the first method that we tried to solve it was using deep learning models, but deep learning models are extremely efficient in extracting information from the data, but then they face problems while classification by, as they have very simple classifiers. So that is and the and converse is true for machine learning approaches, where the data extraction is not very effective in machine learning techniques, but the classification approach is very effective. So we decided to use a hybrid approach, and we considered the models VGG16 and ResNet 50 for the feature extraction to uh, carry out our study. We chose these are models from the ImageNet events that used to produce the most of the biggest groundbreaking innovations in the computer vision field, and two of its biggest successful models were VGG16 and ResNet 15. ResNet, especially for its effectivity in carrying the residual connections, which suggested the extracted features from the initial layers. A part of its weight is also carried on to the future layers, so that we don't lose information as we move through the 50 layers of the ResNet. So that is why we chose these two models. And for
Yeah. Milan, wrap it up
yes, sir.
because we have 1 to 2 minutes left maximum.
Okay, so I'll finish it soon. Yeah, so and
Go
then
for,
the machine
go
learning
for,
techniques.
go for methodology directly result discussion methodology.
No,
Yeah.
okay, so I'll go. So the SVM, KNN, and logistic regression were some of the techniques we used, and we loaded the pre-trained weights from the ImageNet competition, as it is a very well-trained model. And then we had over 300 images, and the data set also we tried to make it as balanced as possible, which was another common problem we saw in many researchers, where there were more ripe fruits than unripe or overripe. So we tried to balance that as well. And then we evaluated the results based on accuracy, mean absolute error, mean square error, R squared score, and the precision. And the highest was given by the VGG 16 feature extractor combined with the logistic regression for classifier as a model, which gave an accuracy of 92%. And then the R squared value, which suggests the fitting of the model, was also 0.73, which is a very good value and does not suggest overfitting as well. So this is how the output of the our problem was. The bananas, if you could see, the labels have been tagged as yellowish green, mid-ripen as well. So as far as the conclusion, the proposed model with the deep learning extractor and the machine learning classifier is is very fast and provides a very high accuracy, and the accuracy is seen equally in classifying into each of the classes. It gives an equal accuracy, which is important since if it's ripe or unripe, it needs to be correctly classified in the industrial application. And since we haven't used any tailored formula, and it was only the training was based only on hyperparameter tuning and model architecture, the same model can be used for classification of other fruits, like such as mangoes or apples or whatever, in any kind of fruits that have a change during their life cycle. So that's it. These are some of the papers that
Thank you.
we have considered. Thank you, sir.
Questions from audience? If we have no questions, then we can move forward. Otherwise, maybe questions from chairs.
No, sir. Go for others.
Okay. So the next paper will. Hello?
Thank you very much, sir.
Thank you, Madan. It was a great presentation. Thank you. So papers 265, rice leaf disease identification using transfer learning. It will be presented by Prince Rajak. Prince.
Hello. My voice is audible, sir?
Yes, you are audible.
My screen is also visible, sir?
Yeah, please go ahead, and you have until 11:42, I would say.
Okay, sir.
Try to finish as soon as possible.
Good morning, everyone. My name is Prince Rajak. I'm tech scholar at NIT Raipur. My paper ID is 265. My topic is rice leaf disease identification using transfer learning. NIT Raipur, National Institute of Technology Raipur, is the institute which is capital of Chhattisgarh. And Raipur is
skip karo.
Okay, sir. Table content, background, introduction, literature survey, problem description, methodology, result discussion, conclusion, and reference. Background: agriculture plays an essential part in Indian economy. It contributes the second largest share in rice output. Rice is harvested nearly all over India. West Bengal produces 146 lakh ton. Agriculture industry contribute 20.1 overall domestic output. In India, rice is the most widely consumed grain. Diseases affect the development and quality of the rice, lowering the production and profitability of the farmer. Farmer used to do manual detection of diseases and sometimes may not identify it. Early detection of these diseases and use precaution, which will help in increasing the production and also increasing the profit. Introduction. In India, rice leaf disease is a major cause for lowering production of rice. The types of diseases are bacterial leaf, brown spot, and leaf smut. We have used the deep learning and transfer learning method and use a pre-trained model like mobile net, dense net, exception nets, etc. Literature survey. In first paper, author used the CNN method with the help of R programming language and use the data set of UCIML and 120 images in 3 class and have gained the accuracy of 86.66%. In the second paper, the author used same method, but they have used the data augmentation. With the same data set, UCIML, which is publicly data set, and have gained the accuracy of 92.46%. In the next method, author proposed color feature extraction method for extracting feature, and SPM classifier is used for the classification of 4 types of data. The dataset was built in Indira Gandhi Agriculture University, Raipur, India, with 619 images and 3 class labels, and have gained the accuracy of 94.65%. In the next paper, author used the two-state CNN has been constructed by BGCC 16. In this stage, the entire data set of 9 classes, which is subdivided into 17 classes. After they have trained those data set, better accuracy, and with mobile net, NestNet, and SqueezeNet, they have gained the accuracy of 93%. The dataset was built in Bangladeshi Rice Research Institute, which have with 1426 images and 9 classes, which was subdivided into 17 classes. Problem discussion: manual detection of rice diseases is a major problem which we have faced, and identification of diseases. The images collected need to be pre-processed. Pre-processing of data is the major cause because of environmental variances. Publicly data available like UCMI has contained less images, which was not very well performing. Traditional method does not support huge amount of data, and huge computational power is also required for pre-processing. Early and automatic detection can solve these issues, which was result in production. Deep learning and transfer learning method are more suitable for these types of problem. Methodology: in this, first we have collected the data set. Then use the pre-trained architecture, and then we have added few layers: flattening layer, two dense layer with two dropout layer with 1024 neurons and 512 neurons and ReLU activation function, and use the as classifier, software classifier, to classify our result. We have used the hybrid rice leaf data set and used to pre-train the pre-trained model with the help of transfer learning. In transfer learning, we have used the pre-trained model and freeze the output layer of the model and add two dense layer with a ReLU activation. In final layer, we have used the software classifier, and then we have compiled all the model and do final tuning and also train the model. We have used the hybrid data set, which consists of 4 classes: bacterial leaf, brown spot, healthy images, and leaf smooth. And we have used multiple pre-trained architecture like Inception as V2, MobileNet V2, DenseNet and VGCC 16, Inception as and VGC 19, and NestNet and ExceptionNet. Next, this is the result which we have gained while training our data set. First, when we use the publicly available data set, we have faced 2 major problems. The first problem was that the training loss and validation loss are very high and compared to training accuracy and validation. So this shows that our model is opaque. And in this, we have gained while performing with the more images. We have gained the accuracy with the DenseNet, and I have gained the accuracy of 94% with the validation part, and I have gained the training accuracy of 98%. This is our training and validation loss graph. With the DenseNet, we have clearly seen that our loss, training loss and validation loss is decreasing, and also for other models. So we have trained different model and have gained the accuracy of with Inception as V2 is 91%, Mobile as V2 is 90, Inception as with 90, and Exception as with 91, and DenseNet 169 have gained the accuracy of 94%, validation accuracy of 94%. And DenseNet perform much better with the training accuracy of 98%, validation accuracy of 94% with 20 epoch, which shows that DenseNet required less training time as compared to the other pre-trained architecture. And conclusion: with the automatic rice leaf identification help farmer and industry to grow their profit, and this method we can also use for tomato and apple and etc. In this, DenseNet perform much better with this, and these are the references. Thank you. Any question?
Yes, Prince, how much more you have achieved over the existing? So have you compared your method?
Yes, sir. We have compared with the method.
So how much?
With the latest survey we have gained, these are the current paper which we have selected.
92% maximum.
We have gained the accuracy of 94.73%, sir.
So
So
same you have achieved, na?
no, sir. 94.65 they have gained. We have gained the 94.71%. And also, sir, we have used 16,000 images, but due to the COVID-19 situation and college institute resources, we are not available. So we have just selected 200 images only. So while performing with the large amount of data, we can also, in future work, we can also increase the accuracy.
Okay, it's fine.
Okay, sir. Any more questions?
Any other panelists or participants, please?
Prince,
How did you? Okay, go ahead.
Yes.
go for your slide number, result analysis slide number 10, I think, 9 or 10.
So result analysis is this 13 slide.
13 slide. But
Yes.
it is not visible.
Can you share the slide again?
Okay, sir. I just also share. Like, wait a second. Now it is visible, sir?
Yes,
Yeah.
yes. Go for
Okay.
14 slide, 14 slide, 14.
Okay, sir. Yes.
14 slide. So how can you say that from this figure your methodology is better? Why? Accuracy training.
Yes, sir. We can say that, as we can clearly see that the training accuracy and validation accuracy varies. This is the huge gap between the training accuracy and validation. Same for mobile net. This model, firstly, while performing with the UCMI dataset, we have gained that we are performing overfitting. So to stop overfitting, we have increased the data augmentation method and also increases our dataset. So we have taken 2,000 images. So with the help of this, we can reduce the overfitting. So while with DenseNet, as the epochs are increasing, so with the less epoch, we have gained the more accuracy. Means we can say that just by at less epoch, our model have gained the huge accuracy. By increasing the epochs, it shows the overfitting. So to stop the overfitting, we just our model stop at 20 epochs. We have also in the result section, we have also, there is not very huge differences in 30 epoch training with DenseNet. Here is that 97% training accuracy and 94.14%.
I think not much better, no?
Sir. So while increasing in our future work, when we increase our data size, so these accuracy is also increasing. So
I
when
have
the college,
little bit doubt. That's why I'm thinking means
Okay.
not the training accuracy and validation of the loss is not means the mentioned parameter. So you go for means something new,
okay, sir.
maybe much then improved the result. So it is better to you.
So yes, sir. In future work, we have also added to use the
Yes.
different classifier. So this can also help in increasing our accuracy.
Accuracy.
Okay. Thank you, sir, for your valuable comment.
Yes, yes. Thank you.
Any more questions, sir?
Dr.
Any more
Rathod, would you like to announce? I think.
Sir, continue, sir. No issue.
Yeah.
Okay. Thank you,
Okay.
sir.
Thank you, Prince, for an excellent presentation and answering the questions. We have the next paper is 284 titled Automatic Fruit Freshness Recognition Using Computer Intelligence. It will be presented by Shanmuga. So Shanmuga, if you're here, please start.
Yes, thank you. Let me share my screen.
Paper ID 284, sir.
Yeah, 284. And you have until 11:43. If you try to finish earlier, that will be better. 11:53. Yeah. Try to finish in 8 minutes.
Is my screen visible?
Yes. Please go ahead.
Okay, so good morning, everyone. Thank you for giving me this wonderful opportunity to present my paper in MSI 2022. The title of my paper is Fruit Recognition and Freshness Detection Using Convolution Neural Networks with the team of myself, Nitya Kalyani, guided by Dr. Elan from Tyagaraja College of Engineering, Madurai. And the table of contents in this slide will be seeing about the background literature survey, problem description, methodology, results and discussion, conclusion and reference of this paper. And regarding now let's start with the background. The main idea of this paper is to detect and analyze the variety of the fruit freshness detection using convolution neural network. This problem mainly arises in our daily routine. Fruit sorting is one of the most tedious works. It requires lots of efforts, manpower, and consumes a lot of time as well. In modern time, industries are approving automation and smart machines to make their work easier and more efficient in the field of fruit sorting. So a smart fruit sorting system has been introduced to identify the type of fruit, and then they tag the name of the specific fruit with grading their freshness including. This is the main background of the paper. And regarding the literature survey, we have mainly concentrated of three main papers. The first one is titled of Automatic Fruit Sorting System using Raspberry Pi. As we have mainly used our toolkit as Raspberry Pi, we are mainly concentrating on the papers which specifies as Raspberry Pis. And in this paper, the accuracy attained is 86% with the convolution neural networks. And the second paper we have referred is the automatic fruit and vegetable detection disease identification. This paper specifies in the disease identification of fruit with the using of machine learning algorithm. The accuracy attained in this paper is 76%. And the third paper we have referred is the color-based quality analysis of fruits for automatic grading using Raspberry Pi. In our paper, the main concept is it is to identify the fruit freshness using that color, texture, and using the main method as the visual. So we have referred this paper, and this paper consists of an accuracy of 86%. And the problem description. The main motto of our paper is to detect and analyze the variety of the fruit and also along with it to detect the freshness using the convolution neural network. This is the quality of the fruit and vegetable is classified through computer vision application. The fruit freshness is identified through a machine learning method. The quality of fruits and vegetable has been clarified through deep neural networks. The fruit types and quality control type is detected through the convolution neural network. This relative accuracy improved is up to 38% is obtained for a small novel assistant artificial neural network in our paper. And the methodology will be explained by Nitya Kalyani. Nitya Kalyani, over to you.
Yeah, am I audible?
Yes.
Here, the methodology we are using is first we are going to import the libraries so that we all know it's a basic procedure. Then we are going to do image data feature extraction as training and testing data from Raspberry Pi. So we are going to use a set of training data which is already preloaded in our Raspberry Pi, and we are going to use testing data as the image that is coming from the Raspberry Pi camera. So now the OpenCV tool, which is used to resize and scale the images of the fruits, it is used to fetch the image from the directories, and it is used to resize and scale it accordingly. Then we are going to load the testing and training data separately into variables such as X and Y. So here the X and Y variable is used for training data image loading, and the X val and Y val is used for testing data image loading. Now, the next step we're going to do is convert the image into arrays for processing. since while converting the image into array of processing, the processing process it takes place in a smooth pattern manner. So after finishing that image feature loading and processing, we are going to use the normalization of array between the characters 0 and 1. Next slide. Here, the main model we are going to use in this method is sequential model, which is used to create a convolution of layers using convert2D, pooling, separable convert2D, etc. So here, after implementing the sequential model, we are going to use convert2D, which is a 2D layer, where the layer creates the convolutional kernel that is like a wind of layer input. So next, we are also further analyzing our array of images using max pooling, which is a sample-based process where the objective is to downsample that input presentation, which contains an image, hidden layer, etc. So we are also using dropout, which is like used for removing or dropping out the input layers, which may be used as input variable in data sample or activation from the previous layers. Then before the final step, we are going to use flattening, which is used to reshape and tensor such a shape into equal number of elements present in the tensor. So it is used to convert a 2D array of image into 1D. So the final step, which is the densing of the layer, the dense layer is used to regularly and deeply connect the neural network layer. It is like a deeply connected layer. It is most commonly used layer in the convolutional neural network. So it returns the output as the final layer. So here we are using reduced Aileron plateau so that the learning rate of the images can be reduced when no further improvement is there, so that it doesn't waste any time in segregation of the input layers. So using neural network, again, the process we saw above, we are going to fit the model, and here we are going to use 5 epochs. So first we use 30 epochs. Since the number of images we are using, the training images we are using as 9,000 training images.
Nithya, you have 1 minute. Try to wrap up. Okay.
Okay. We are using 9,000 training images and 2,000 testing images for getting the accuracy at first time. So after getting the input from Raspberry Pi, we are reducing the epoch from 20 to 5, and in each batch we are using 20 images. And then we are plotting the accuracy and graph. So next image, explain. Yeah. So this is the accuracy we are getting. The val accuracy is 89 and normal accuracy is 94 for sorting and freshness separately. So first we are doing the sorting process, then we are doing the freshness process. Next slide. So these are the other methods from machine learning which we have used to compare with our present model now. So since from this comparison, it is clear that our convolutional neural network accuracy is highest among the other methods which we have used from machine learning. Next slide. This is the hardware setup of our project. Since we carried this project in our college, the time and resources are somewhat limited, but we try to get the maximum output possible as we can. Next slide. So here they are the conclusions. So the reduced Aileron plateau, it is as we discussed above, it is used to reduce the learning rate when there is no other improvement, so it reduces the time. So this method, it attains a very large accuracy, above 90% with minimum amount of time. So if we use a better processor, the time can be reduced up to 40 seconds. Since we have a lack of hardware and processing system, it took 3 minutes for us. Thank you. Any more questions?
Thank you so much for the presentation. I don't think we have time for questions because we have only 6 minutes, and I don't want the last presenter to, So the next presenter is Sabia Fatima, who will be presenting paper number 316, CNN-based Apple leaf disease detection using pretend Google Net model. So Sabia, you can move forward.
Hello. Am I audible?
Yes.
Good morning, all. Is my screen visible, sir?
Yes, yes. Go for first slide. First slide.
Oh, okay. Okay.
And also get into presenter mode. So that will be.
Good morning, everyone. My name is Sabia Fatima, research scholar in National Institute of Technical Teachers Training and Research, Chandigarh. The title of my paper is CNN-based apple leaf disease detection using pre-trained Google Net model, and the ID of my paper is 316. And as we all know, the apple is very important fruit plant, and it is very famous worldwide due to nutrient importance. And according to the Food and Agriculture Organization of United Nations, India is the 6th biggest apple producer all over the world. And it is also reported from the same reference that in this report we can see that the area of production is given in hectare, and the tons of production in tons is also given, and the productivity is also given. So this record is taken from 2011 to 2018. So in this report we can see that the production area is increasing, but the productivity is decreasing. So the detection of apple plant disease is one of the current challenge in computer vision and the agronomy. And from some research, from some study, it is found that India lose rupee 50 crore in a season, which is 10% of India's total income. And the naked eye inspection of the disease is very costly and time consuming. So from the study, it is found that 85% of the plant disease are caused by fungi, and 80% symptoms of apple plant disease appears in a leaf. So there is a strong motivation to implement an efficient apple disease recognition system using leaf images. There are some selective papers are mentioned in this literature survey. The first one is a novel deep learning method for detection and classification of plant disease, published in Complex and Intelligent System, Springer, in 2021. Albatta et al. Has used the plant village dataset and used the DenseNet 77 model for feature extraction, and found that their work is robust to noisy sample, but there are some limitations that they had used minimum small data set, and this proposed methodology is computationally expensive and time consuming. The paper machine vision based plant disease recognition is published in Journal of King Saud University Computer and Information Sciences elsewhere in 2020. Author MT Habib et al. Captured the 129 images manually, and in pre-processing they has resized the images. Contrast enhancement has been done, and the color conversion from RGB to LAB color space has been also done. For disease response segmentation, they had used the k-means clustering method, and the GLCM features has been extracted from that disease spots. And these features are classified by SVM, and found that SVM outperforms naive Bayes and decision tree. And the limitation of this work is data set is very small, and k-means required initial value, which is the initial centroid and best segmented cluster. And
better to go methodology section, please.
Okay. This figure shows the flow diagram of proposed methodology, and here there are some major steps in this methodology. First one is data acquisition and pre-processing, and second one is retraining of Google Net CNN. Third one is classification of images, and the fourth one is performance evaluation. So in first step, we have collected the data set from this link, github.com, SP Mohanty, Plant Village dataset. Our dataset's name is Plant Village dataset. And in this dataset, there are 3,171 images having 4 categories, 3 disease and 1 healthy category. So there are 630 images of apple scab, 621 images of black rot disease, and 275 images of apple kedar rust. and there are 1645 images of healthy leaves. And then we have pre-process. In the pre-processing step, we have only resized our images in which was originally in size 256 into 256 in 3 color channel, and after resizing the image, its size is 224 into 224 into 3 pixels, which is the size of the input data of GoogleNet, input layer of GoogleNet approach. And after splitting our data set into 70 15 ratio for training, validation, and testing, we found 2,221 training images, 475 for validation and testing images. In second step, we are retraining and fine-tuning the GoogleNet CNN. So this is the end-to-end learning architecture where we extract the features and classification automatically. To extract deep feature, a training set of images is fed into transfer learning based GoogleNet. We have fine-tuned the model by modifying training parameters like optimizer, initial learning rate, mini batches, maximum epochs. Then we have modified a fully connected and classification layer, which is a 142nd and 144th layer of the GoogleNet model. Then we have fine-tuned, after fine-tuning the model, we retrained the GoogleNet on our plant village dataset. In this step, the last layer has a softmax. The last layer, that is the classification layer, has a softmax activation function, which gives each output a different probability for the input image. The model picks highest as its class prediction, and after training and validation, finally the model is tested using test set, and then performance of the model is evaluated using precision, recall, accuracy, and F-score. So this proposed GoogleNet model is implemented in MATLAB 2020B with 8 GB RAM and Core i7 processor. Our training of the proposed approach is completes in 107 minutes and 22 seconds. So fine tuning increase the accuracy and reduce the training time. In this figure shows the training progress of retraining GoogleNet over our plant village. Here we can, in this we can see that the validation and training accuracy is increasing while the validation loss is decreasing, means the network is learning properly. So the validation accuracy achieved 100% in our method. And we can also see the hyperparameters we use, that the learning rate is 0.003 and the frequency is 555 iteration and the maximum epoch is 6. This figure shows the confusion matrix for our proposed work. Here we can see that our proposed methodology overall accuracy is 99.8% with misclassification rate 0.2%, and the precision class-wise precision of apple scab is 98.9, black rot and other categories achieves 100% precision, while recall for apple scab, black rot and kedar apple rust achieve 100% recall, and healthy image achieved 99.6%. This table represents the comparative analysis of proposed work with existing methods. In first one, Arthur Wang et al. Has used these all the plant village dataset, which is used in our proposed work also. So Wang et al. Has used plant village dataset, and having only one disease category, they have achieved 90.4% accuracy in their work. And Khan et al. Has achieved 98.6% by using only 2 disease category, while Geeta Ramani has used all the categories of this plant village dataset and achieved 96.46% only. And Attila et al. Has used all the categories and achieved 99.91%, which is greater than our proposed work's accuracy. But there are some improvement in our precision and recall, which is 99.79 and 99.9%. The drawback of this work is also the training time, which is 643 minutes and 3 seconds, which is very larger training time in comparison to our proposed work. While our proposed work training time is 107 minutes and 22 seconds. And Albatta et al. Has used all the categories of plant village data set and achieved 99.15% F1 score. But they have used small data set.
Yeah, I
And-
think in the interest of time, we could conclude. Okay. So if anybody has any question, otherwise we'll conclude the session, I guess.
Yes.
Yeah, just
Yes,
leave
yes.
the
Okay, thank you.
leave the slide, conclusion slide like this. Yeah.
Okay, thank you.
These are the references.
Thank you. Yeah. Anybody has any question? Otherwise, we'll
No.
just thank all the presenter and audience. And
sorry for interrupting, sir. Before leaving, I request all the session chairs and the presenters to turn on their camera.
Thank you, Dr. Rajesh and Dr. Raghav Prasad and Dr. Vijay Singh Rathod for sparing your valuable time and conducting the session in such a nice way. Thank you. Thank you.
Thank you so much.
Thank you, sir.
One more request, sir.
Thank you.
Chairs are requested to fill out the Google Forms for evaluation so that we can award the best paper. And at last, I'd like to thank all the session chairs on behalf of NIT Rapport and the organizing committee of the conference. Thank you, sir. Thank you very much.
Thank you, Rajesh sir. Vijay sir, namaskar.
Thank you, sir. Thank you.
Can I later?
Can we have a group photograph?
Sir, already taken.
All the participants and session chairs. Davis, can you take one group photograph?
Sir, already taken.
Already taken. Okay. Thank you. Thank you, sir.
Thank you. Can I leave now, sir? Let us leave.
Yes. Thank you, sir. Thank you for sparing your valuable time.
Okay, session is completed. Okay, thank you.